In this video, we'll look at graphing a piecewise defined function that involves constants only. A function that is defined piecewise means that it is defined according to different rules depending on the input x. To graph, you have to figure out the endpoints of each segment as ordered pairs, and whether or not to use an open circle for strictly less than or strictly greater than, or a closed circle for less than equal to or greater than equal to. You create your graph in each segment according to the rule given for that part of the domain. In ALEX, you may need to use the cutting tool to limit your graph to a particular x interval. Once you select the cutting tool, you type in the ordered pair of the point where you want to start cutting, then use the eraser to get rid of the unwanted part of the graph. The graph is continuous if there are no holes or breaks in the graph. So if you could draw the graph without actually picking up your pencil from the paper, then you consider it continuous. In this video, we're only going to look at piecewise defined functions where the y values are constants. So here we have h of x equals 0 if x is greater than -2 and less than or equal to -1. 1 if x is greater than -1 or less than or equal to 0. Y equals 2 if x is greater than 0 and less than or equal to +1, and y equals 3 if x is greater than 1 and less than or equal to 2. All right, so the first one says y equals 0 if x is between -2 and -1. So 0 is down here. So I have my graph going like that. It will be a horizontal line because y is a constant, y is 0. Now I have to figure out the endpoints of that segment. Here I have x is strictly greater than -2. So that means that at -2, I have to have an open circle that's not filled in to show that my graph is not defined at that point. But at -1, I have a less than or equal to that line underneath. And so that's going to translate to a filled in circle. So there's my first segment. Now, if x is between -1 and 0, then y equals 1. So I'll have an open circle here because of the strict x is greater than -1. And then at 0, I'm going to have a filled in circle. Remember, y is 1. So I'm going to have a filled in circle there. And I go ahead and connect. Okay, let's look at the next one. Y is equal to 2 if x is greater than 0. So there's where x is 0, and less than or equal to 1. So the or equal to makes it a filled in circle. And then y is equal to 3 if x is greater than 1, strictly greater, so an open circle, and less than or equal to 2. So these parts with the x is defining the domain part and whether you have an open circle or filled in circle. And then these parts here, the 0, 1, 2, 3, those are defining the y. Let's look at a couple more examples in ALEX. I have one pulled up here. So we have h of x equals -1 if x is greater than -2 and less than or equal to -1. So I'm going to select this segment tool in Alex. Y is -1 if X is between -2 and -1. So X is the horizontal between -2 and -1. My Y was -1. Now, when X is -2, it's a strict inequality. So I'm going to select the hollow dot and put that at the left end of my segment. And then at the right end of my segment, when X is -1 and Y is -1, I have a or equal to, so I'm going to select the solid dot and put that at the right end of my segment. Select the segment tool again. Y is 0 if X is between -1 and 0. And again, I'm going to have a hollow dot on the left end and a solid dot on the right end because of the strictly less than and then the less than or equal to. The next one is Y is 1 if X is between 0 and 1. And I'm going to have a hollow dot on the left end and a solid dot on the right end. And then select the segment tool again. Y is 2 if X is between 1 and 2. And I'll have a hollow dot and a solid dot here. All right, let's do one more. Okay, here's one where we have g of x equals -5 if x is not equal to 0, and 2 if x equals 0. So I'm going to go ahead and do a line. Y is -5. Oops, let me clear this. I'm going to do a line. Y is -5. There we go. Y is -5 is a solid horizontal line, but that's only if x is not equal to 0. So when x is equal to 0, I have to put a solid dot, a hollow dot when x equals 0 to show that that line is not defined there. And then y is equal to 2 if x equals 0. Since that's a single point, x equals 0, I'm going to just select the solid dot and put the point 0, 2. X equals 0, y equals 2. So that's going to be my graph. There we go. I'll have this horizontal line at y equals -5 with a hollow dot at x equals 0. And then I'll have the point 0, 2. All right, so as you can see, if you have a single x value, it will just translate to a point. If you have the less than or equal to, like we did in these examples, then it will translate to a horizontal line.